All right, so welcome to Chapter 5, Accumulating Change on Limits of Sums and the Definite Integral. So this is Section 5.9 on integration of product or composite functions. So algebraic manipulation before integration is sometimes needed. So it's because we have functions that aren't initially in the correct form to apply any simple antiderivative rules. And so we have to do some algebraic manipulation. So we're going to look at some examples of that. And then we'll move on to the next thing after that we have to consider. So the first one we have is we have this f of x is 7x times x squared plus 5. So as it is, we really can't do anything. But what we could do is we can manipulate and we can multiply the 7x times x squared and the 7x times the 5. And when we do that, we get the 7x cubed plus 35x, which is basically when we take the antiderivative of that, we can take the antiderivative of the first piece plus the antiderivative of the second piece and plus our constant, and we'll get our answer. So when we do this one, that's going to be 7x to the fourth over 4, and that's going to be 35x squared over 2 plus our c. So again, first we had to multiply it out to get it to be able to be in a form we could actually integrate. Now, other ones are the same kind of things, but we have to think about how they work. And these are the things like we have exponentials or powers that are different than just a normal power. So if we have exponentials, we have to remember all the way back, if we take e to the m times e to the n, it's going to be e to the m plus n. Or any base is going to be just add those powers together. So if we have this times this binomial, we're going to multiply those two. That's going to be e to the 3x plus 4x, which is what? Well, that's 7x. And e to the 3x times 4 is just going to be 4e to the 3x. Now, this is easy to take the antiderivative of because we know how to do this one and we know how to do this one. So when we do e to the 7x, what's that going to be? Well, that's going to be e to the 7x divided by our variable, our number up here, 7. And when we do this one, that's going to be 4 times e to the 3x divided by that 3 and then plus our c. Now, when we have things with odd powers, like with roots, what do we do there? Well, what we have to do is we have to basically multiply them together after we've converted them to fractions. So instead of the cubed root of x, we're going to change it to x to the 1/3. And so then we can take x to the 1/3 times x squared and x to the 1/3 times 8. And as you can see here, when we do that, x to the 1/3 times x squared, that's going to be the x to the 7 thirds, and this one is going to be 8 and x to the 1/3. Okay. So when we get that, what do we do? Well, we integrate that. We know how to do that. That's going to be x to the 7/3 plus 1 over the thing. So 3 plus 7 is going to give us 10/3 over the 10/3. And then we have 8 times x to 1/3 plus 1 is going to be 4/3 over 4/3, and then plus our c. Okay, so that's our first one. All right. Now, what about this one? Sometimes we're gonna have to manipulate our fractions this way. And so we'll have like a binomial, maybe even a trinomial over a monomial. Could be even a binomial, but most of the time we're looking at monomials in this case. And what we're gonna do is we're gonna take this piece and then say plus this piece. And so we're going to break it apart into two fractions. And two fractions, we can work with that because then we can take the integral of the first fraction plus the integral of the second fraction, and that'll work. Well, if we take the 15t cubed over 5t squared, well, 5 goes into 15, 3, and t squared goes into that once, we have basically a 3t. Now here the 5's cancel and there's going to be 1t on the bottom, so it's going to be t to the negative 1. And so when we do this integral, or antiderivative, we're going to have 3t squared over 2 plus, and then this is going to give us ln of t plus our constant c. Okay, so that's kind of a simple way to work at this one. We just take and do pieces, okay? And so we've done that with other things, if we had imaginary numbers, we had to get it into the a plus bi format, and sometimes it was a plus bi over 4 maybe, and then we had to take it and say, well, that's a over 4 plus bi over 4, and so that again is back into the a plus bi format. It just has fractions for that a and the b. Now, sometimes when you get going, we're going to have something that looks like this, and this, and this, and these cannot be reduced into simple forms that we can actually do. And so those functions basically are not able to be rewritten into an algebraic manipulation that we can easily integrate. So sometimes we're not going to have things that are nice, and we have other things we can do when we get something like that, and that's going to come up in the next part.